Hello everyone, I am Rahli Chouaib, fourth year PhD in the Electromechanics Department, Mechatronics stream from Annaba from Algeria. My title of my project is Improved Direct Control of Single-Stage Photovoltaic Powered System. This paper introduced a novel control direct quasi-Z-source inverter topology as a viable alternative to conventional two-stage converter in a photovoltaic system. The proposed control strategy effectively merge duty cycle and modulation index within a space vector space with the SVPWM framework for both DC and AC control. To assess the system performance under diverse weather conditions, we use the incremental and P&O for MPPT algorithm. Regrowth simulation conducted using MATLAB Simulink software. Introduction. The importance of sustainable energy has increased in recent time due to the depletion of the ozone layer and energy prices. For this reason and the more, most developed countries have turned to renewable energy sources, which improve air quality, create jobs, and reduce greenhouse gas emissions. Solar and wind power, two of the most popular sources of sustainable energy, have had a scientific impact on the growth of the industry by making renewable energy more affordable and comparative with traditional fuel. A complete switch to green energy is now possible thanks to rapid growth of renewable energy sources, but there are still many hurdles to everyone. Photovoltaic conversion of solar energy stand out as one of the most effective and promising technique. Traditional PV systems have relied on the two-stage conversion processes incorporating both DC-DC and DC-AC stage. However, this approach presents a challenge in terms of efficiency and system complexity. The Z-source inverter has emerged as a compelling solution, offering a multi-object optimization for PV system. This innovative technology allows for single-stage power conversion while simultaneously enable maximum power tracking control. Directly optimizing energy conversion. Furthermore, the Z-source inverter contribute to improving the overall reliability of photovoltaic system, addressing a critical concern in renewable energy deployment. Current control strategy for Z-source inverter is a photovoltaic application typical employ and direct model using PA regulator to generate a control syntax. Why effective there is a room for improving term of efficiency and response. In a two-stage PV system, voltage used to boost the PV input voltage and DC to AC conversion. The first stage, a DC-DC converter, is used usually incorporating a boost of or back boost converter to transform the full DC power of the PV array into a higher or a lower DC voltage. In the second stage, a voltage source inverter VHC is used to convert the DC into AC for the load. This paper proposed a multi-objective optimization approach for photovoltaic system using a quasi-Z-source inverter. Our method incorporates MPPT control with direct duty cycle control, aiming to enhance system performance and energy yield. This novel approach promises to advance the state of the Earth in photovoltaic energy conversion, contributing to the broad goal of optimizing renewable energy sources for a sustainable future. A PV modeling system. The photovoltaic panel are a technological equipment that facilitate the direct conversion of a solar radiation energy into electrical energy. By absorbing a photon from the sun, they can energize the electron and get them into electrical circuit, where they produce a current and a voltage. A current source, a diode, and the cells and the parallel resistors consist the electrical circuit that makes the solar cell circuit. We have made the blending of our panel for different climatic conditions such as irradiation and temperature. A different MPPT algorithm. The MPPT are maximum power point and tracking optimization to electrical working point of a photovoltaic PV model of array for optimal power protection and the power availability. Solar model optimized energy protection is complexly linked to temperature and the radiation. MPPT algorithm optimizes power protection by monitoring and adapting to the most economic operating point, even when conditions change. Perturb and observe and incremental conditions are used to mitigate photovoltaic PV. Energy extraction. P&O algorithm. The perturb and observe method predicts changes to photovoltaic panel operating voltage and observe how it affects PV system power. This perturbation is caused by slow adjusting the duty cycle of the power converter between the PV and the panel and the load. When the PV model operating point on the left side of the curve, the P certificate is positive. Power output can increases and the duty cycle decreases toward MPP. When the model's operating point is on the right side of the curve, the P or the C is negative. The duty cycle arises to approach MPPT. INC algorithm. Photovoltaic system for frequently employed the incremental condition maximum power and tracking algorithm to maximize the power extraction for the solar panel in order to find the solar of the power voltage PV curve. It continue compare the instant conduction EV to the incremental conduction DE TV. The program can find the maximum power point by studying the relationship between this number and the logging of the peak of the PV curve. Our improved technical system, direct control system. The use of direct duty cycle control in a power exchange based on quasi-Z-source inverter fed by PV generator offering two key advantages. Firstly, it's a minimal steady state oscillation leading to smooth power output. Secondly, it ensures faster tracking of the maximum power MPPT even under challenging environmental conditions, including partial shading and scientific irradiation fluctuation. The other has minimizing the number of static converter and the conversion chain increases the reliability and overall efficiency of this conversion chain. Result anticipation. In this way, work we present the development of direct SVPWM technique and evaluate its performance using incremental and the period algorithm for the quasi-Z-source single stage system, which operate based on maximum power point tracking. The proposed system consists of a photovoltaic model with the three parallel and the 9 series model, a cause-Z source and LC filter, and these than resistive load. The solar model has a maximum power uh, of 2000 watt under standard operating condition. We observe a maximum power point tracking approach across various situations, such as the temperature and the variety of irradiation. Conclusion. This study introduced a novel control technique for a quasi-Z-source inverter using direct control of the duty cycle based on space vector pulse width modulation and conducted a comparative analysis with two popular maximum power point approach, such as incremental and P&O. The direct control method based on direct control of the duty cycle accelerate response time compared to traditional PE regulator based control. The duty cycle produced by this method is derived from the combined P&O and MPPT and SVPWM technique, ensuring efficiency, energy conversion, and system performance. The result of this study highlighted that the incremental algorithm produced more consistent and faster result compared by PM2, particularly under rapidly changing climate conditions. This underscores the efficiency of the incremental algorithm in optimization energy yield in photovoltaic system. By controlling the quasi-Z cells with the proposed the SVPWM control method, multi-object optimization of a PV system was achieved, improving stability, eliminating the need for a PE controller, and ensuring operating at optimal power. This approach not only enhances the performance and the reliability of a PV system, but also contributes to advancement of renewable energy technology, promoting a more sustainable future. Future research could further explore optimization technical and the application of this approach to the other renewable energy source. Thank you for your attention.